topic in itself, it is similar to that. Joule's law of heating effect. Okay, how Joule in 1941, in this year, he studied experimentally without doing mathematical calculations separately in the lab what he has found, how the heat is produced by a current. Okay, so what he found is that he said that the amount means quantity of heat produced in the conductor H is, okay, directly proportional. Directly proportional means it depends directly. If it is more, it has to be more. What are the things it will depend? You already know them. It will directly depend on the square of I. That is what, how to write? H is directly proportional to this symbol, directly proportional to I square. Okay, heat generated will be more as the square of the current increases. Number 2, again proportional to what? He says resistance of the conductor. This means H is directly proportional to R. And also third one, he said time for which it flows. For 1 hour more heat, for half an hour less heat, like that. So H will also depend on T. Remember, H will depend most on the current because its dependence on the square. Double means multiple. Okay, so if the current is slightly increased, heat will be generated more, and other factors are also there contribute. Together he combined and he found that the heat should be depending on 3 things. What is that? I square, R and T. This is what he has formulated. Okay, now after that, now the next topic was practical applications of heating effects of electric current. Some examples are electric bulb itself. Electric bulb, you know, the usual electric bulb, old days electric bulb, these days LED and all there. That is not the earlier bulb. Inside you will see one wire is there. Okay, this is made up of tungsten, TUNGST, and its chemical symbol is W. In the periodic table you can see this. Tungsten has a unique property that it has very high resistance. It has what? High resistance. If that, what will happen? Very high resistance and high melting point. That means it will not damage easily. High melting point. It will not convert into liquid very easily, even at very high temperature. Okay, and it can be made into fine wires. Very very thin wire we can make it, and it's not brittle, it will not break. So these are the properties an electric bulb has. Electric bulb filament, this is called filament used. Now when you provide electrical energy here, lot of energy, this will give current here pass through. If the current passes through this high resistance, okay, high resistance, the temperature of this filament will increase. Almost how much? 2000 degrees centigrade. This much it will increase. You remember 100 degrees centigrade water boils and very very high amount of heat is produced here. When this becomes very hot, it will start emitting light, or emit white light. This is what we say the bulb is glowing. Okay, so this is how the application of heating effects has given us the light which you can see in the dark. To see things you can use it. This is the your invention of electric bulb is because of this application. Okay, now the second use, very useful, is a fuse wire. You must have heard the name fuse. Fuse wire is also made because of the heating effects of current. This is the application. The earlier was electric bulb used in safety devices. How? Let me make a device. Suppose you're running some very important instrument here. This is very important instrument at your home, okay, and some current is flowing here. I'm writing this is the current symbol, very high, very usual current it's going. Here I will put my fuse. Just for example, this is a fuse here. So normal wire, what we use in our homes, it will carry the current, it will heat up, nothing will happen. Okay, when suddenly very high current comes, it can happen, okay, due to some fluctuations or whatever it is. During that time, this gadget may get damaged when high amount of current enters. So usual time it is okay, it is running very nice, but once in a year, twice in a year, it may happen that suddenly it increases. During that time we put one fuse here. In the fuse what we use, aluminum, copper, iron, lead, all these pure metals made up of this wire, or some alloys of copper, tin or lead tin also can be used. This is very fragile, very weak type of, weak means in the sense it cannot withstand, it cannot tolerate the heat produced due to the current. Suddenly if that current which was I here, suddenly if it becomes I more, then here you know already that H is proportional to I square. When the current increases, this will become H, very big. Okay, I square will be big, then H will be big. This H will be big means the fuse will get damage, it will break, but no problem, we have another fuse to replace it. We can replace it here and use this. The gadget will not be damaged because the circuit will be, this will be disconnected, and then it will remain safe. This is the way. So we have fuse everywhere in gadgets these days. You can understand 1 ampere fuse, you can see in the vehicles also, you can see 2 ampere, 3 ampere. This will decide how much current it should carry. More than that, it should break. It is better to break. Do not use here good connection. Okay, this poor type of heating conduction, the heating behavior will help you safeguard the gadget. So this is prevented. This may be computer, this may be fridge or whatever it is. Okay, so this way fuse will work. It is like you have a rope. This rope here, a very loose connection is kept so that here current is not reaching. Before reaching here, it will stop, and here it will get breakdown. This is how the fuse works. Okay, you can read in your books or see some videos as well. So this is all in this class. Thank you.